Okay, so today we are going to be talking about maybe a bit of a subtopic in percentages, but I thought I'd touch on it anyway because we are going to be talking about the idea of complementary percentages. And I've included this because this word complementary comes up quite a bit in mathematics. And we're going to examine that in the context of percentages. So, where have we seen this before? Well, some of you may remember in geometry, we looked at complementary angles. So when we have a 90-degree angle here, a right angle, and we put a straight line through that, then we get two more angles, here and here. And these ones were what we called complementary. So they added up to 90. And we saw that, well, let me just tidy this up a little bit. We said that, well, if we were given one angle, so say we knew that this angle was 35, we were able to find this unknown angle by saying, well, we know that both of these add up to 90 degrees, so this one must be 55 degrees. We also dealt with the idea of complementary probability. So when we rolled a dice, when we rolled a die, I should say, um, and when we said, well, the probability of getting any of these numbers 1 through to 6 was 1 over 6. So we could say that, well, if I know that each of these is 1 over 6, say I was to ask you, well, what is the probability of rolling something that is not a 5? So what we did was we said, well, all of these probabilities added up to 1. So we said the probability of not 5, well, there's 5 out of 6 other events that are not 5, because 5 makes up 1 out of the 6. So we could also say that, well, the probability of rolling not 5 is 1 minus the probability of rolling a 5, which was 1 minus 1/6, which gave us 5 over 6. Sorry, that subtraction sign is very wonky. Let me fix that. Now, the same idea applies to percentages, because when we look at percentages, at least in the context of a portion of something out of 100, well, we can deal with a very similar idea, and we often get this idea of complementary percentages in particular worded problems, which I'll show here. So if you look at these questions, they follow a pretty similar form to especially the complementary probability questions. Now, let's look at question A. So if 12% of the students are away from the class, what percentage of students are present? Well, I'm going to write P for students present, and I know that the students present plus the 12% of students that are absent makes up 100% of the class. Therefore, I can find the percentage of students that are present by saying, well, okay, what number adds to 12 to give 100? And we can also, by manipulating our equation, we can express this as 100% minus 12%. So that gives us that the percentage of students present was 88%. Now, let's look at a second example. So we're told that in a class spelling test, if James got 86% of the words correct, what percentage of the words did he spell incorrectly? So this is the same idea as our complementary probabilities, for example. We had a percentage of correct, and then we need to find the percentage of not correct. And we do this in a very similar way, because we know that, let me say that the percentage of words incorrect, I'm going to write that as I for incorrect. And that, as well as 86%, would make up the 100% of the words in the spelling test. This idea of the whole. So remember, in probabilities, we talked about every event possible adding up to 1, and the 1 was the whole. Our 100% here is the whole as well, because 100% as a fraction is 100 over 100, and that equals 1. So we have this idea of the whole coming up again. And we have the incorrect answers plus the 86% that he got correct give us the whole, our 100%. So what would be our percentage of incorrect ones? Well, we can once again say that that is 100% minus 86%. And we are going to end up with 14% here. So this is just a little video to show you that the idea of complementary percentages work in a very similar way to what we had before. So I'll see you guys in the next video.